Chapter 1: The First Useful Hour. If the words artificial intelligence make you picture a dishonest chatbot, a job loss headline, or a machine pretending to be human, your reaction makes sense. The public conversation often compresses hundreds of different tools and uses into one anxious image. But that image leaves out the most practical question. What can a normal person actually do with this technology on an ordinary Tuesday? This film is for the curious beginner. You do not need to code. You do not need to buy 5 subscriptions. You do not need to become an AI evangelist. You need one real task, a clear boundary, and enough judgment to decide whether the result is useful. Imagine 3 outcomes. First, you have a document that has been sitting in your inbox because it is long and confusing. An assistant helps you build a plain language map of its dates, obligations, and questions. Second, you have rough notes for a small business idea. An assistant turns them into a 1-page brief, a checklist, and 3 risks you had not considered. Third, you want to learn something difficult. An assistant explains it at your level, quizzes you, notices where you are confused, and tries another explanation. None of those outcomes is magic. None should be accepted without review, but each one can turn friction into motion. That is the positive case for productive AI, not a machine living your life for you, but a flexible layer between your intention and a useful first result. Over the next 45 minutes, we will build a beginner field guide. We will look at research rather than slogans. We will show real stories, including accessibility, medicine, science, disaster preparation, customer support, coding, and family businesses. We will look at what common plans actually cost and why the cheapest starting point is often free. We will build 3 everyday workflows from beginning to end. And we will keep a human in the loop, because useful optimism is stronger when it has boundaries. Here is the central promise. By the end, you should be able to choose one low-risk task, give an AI enough context to help, challenge the first answer, verify what matters, and turn the conversation into something you can actually use. Operator Tonka will return at the moments where the excitement needs a stop button. His question is simple: where could this fail? That question is not anti-AI. It is how we earn the upside. Start with a small thought experiment. What is one task you have delayed because the first step feels vague? It might be writing an email, organizing receipts, understanding a form, comparing products, planning meals, studying for a test, updating a resume, creating a simple website, or deciding what questions to ask a professional. Hold that task in your mind. By the end of this film, you will have a safe way to begin. Chapter 2: A workable mental model. The easiest way to misunderstand AI is to treat it like either a search engine or an oracle. It is neither. A modern assistant is closer to a very fast, very broad, sometimes brilliant, sometimes unreliable collaborator. It can work with language. Many systems can also inspect images, hear audio, read files, analyze tables, write code, generate media, search the web, or call connected tools. The exact abilities depend on the product, the plan, the model, the permissions you grant, and the region where you live. Those details change quickly. The durable idea is that an assistant can transform information and help coordinate steps. When you ask a question, the system does not open a little drawer containing the one true answer. It produces a response based on patterns, context, instructions, and whatever tools it can access. That makes it powerful for drafting, explaining, comparing, brainstorming, restructuring, and translating between forms. It also means the answer can sound confident while being wrong. The first beginner rule is this: fluency is not evidence. A smooth paragraph is a draft. A number needs a source. A legal conclusion needs a lawyer. A diagnosis needs a clinician. A payment, publication, account change, or message sent in your name needs your approval. The second rule is that context is leverage. If you say, write an email, the assistant must guess almost everything. If you say, write a 2-paragraph email to a longtime customer whose shipment is 3 days late, apologize without blaming the carrier, offer 2 options, keep the tone calm, and end with one clear question, the system has a workable brief. A useful brief has 5 parts. Goal: what result do you need? Context: what happened and who is involved? Constraints: what must be included or avoided? Evidence: what files, links, examples, or data should the assistant use? Definition of done: what would make the output usable? The third rule is that iteration beats incantation. There is no universal perfect prompt. Good work usually comes from a loop. Ask for a first pass, point out what is missing. Request alternatives, ask the system to state its assumptions. Ask what evidence would change the answer, then make the final decision yourself. The fourth rule is that permissions matter. Chat is one request and one response. An agent may read folders, run code, use a browser, create files, or take actions through connected accounts. More capability creates more leverage and more risk. Start with read-only access. Prefer reversible tasks. Review drafts before sending. Never give a system more authority than the task requires. A practical risk ladder helps. Green tasks are reversible and low stakes. Brainstorming, practice questions, formatting notes, creating checklists, or drafting copy. Yellow tasks need verification. Research, spreadsheet analysis, product comparison, code, contracts, or anything based on current facts. Red tasks require a qualified human and strict controls. Medical treatment, legal rights, investments, safety systems, security changes, hiring decisions, or sending money. The goal is not blind trust, it is calibrated trust. You give the tool a job small enough to inspect, and the result earns the next job. Chapter 3. Where the leverage is. Productive AI becomes easier to understand when we stop organizing it by brand and start organizing it by verbs. The first verb is explain. You can paste a confusing passage and ask for a plain language version, an analogy, a glossary, and a short quiz. The assistant can adapt the explanation after you say what still does not make sense. This is especially useful because learning is not one answer. It is a conversation that changes as your understanding changes. The second verb is transform. Rough notes can become an outline. A transcript can become action items. A long policy can become a checklist. A table can become a chart. A voice memo can become a project brief. The information is not automatically correct because it changed form. But the labor of creating a useful first structure can shrink dramatically. The third verb is compare. Give the assistant your criteria before asking for a recommendation. For a laptop, include budget, software, battery needs, screen size, repair concerns, and country. Ask it to separate verified specifications from opinion, cite current sources, and tell you what it could not confirm. A comparison without criteria is entertainment. A comparison with criteria can support a decision. The fourth verb is challenge. Ask the system to argue against your plan. What assumption is doing the most work? What could make this fail? What would a skeptical customer say? What evidence would reverse the recommendation? This is one of the highest value uses because the assistant does not have to be the final judge to help you see around a corner. The fifth verb is create, and in this context, creation can mean a social graphic, a lesson plan, a meal plan, a prototype, a spreadsheet formula, a presentation, or code. Small tool. Creation becomes safer when you define what the artifact must do and how you will test it. The sixth verb is organize. Ask the assistant to group information by project, urgency, owner, deadline, or decision. It can propose a filing system, a weekly review, or a simple dashboard. Keep private information inside the boundaries you understand. A clever organization system is not worth exposing data you did not mean to share. The seventh verb is automate. A repeatable task can become a workflow. Gather inputs, classify them, produce a draft. Flag exceptions, and wait for approval. Automation should begin with observation. Run the workflow manually. Keep a log, make outputs easy to undo. Only then consider scheduling it. Here is an example prompt that uses all 7 verbs. I run a local service business. These are 20 anonymized customer questions from the last month. Group them by theme. Explain the 3 biggest sources of confusion. Draft a clearer FAQ. Identify any answer that depends on policy or law. Create a checklist for human review. Then propose a read-only weekly process that reports new themes without sending anything. Notice what that prompt does not say. It does not say, run my company. It defines a bounded job and a stop condition. Now the retention test. One clever prompt is not a workflow. A workflow has repeatable inputs, a known output, a verification step, and owner, and a rule for what happens when the system is uncertain. If you cannot describe those pieces, you have a promising conversation, not dependable automation. For your first week, that is enough. Pick a task where a first draft has value and a mistake is easy to catch. The best beginner win is not a spectacular demo. It is a small result you will use again. Let us make those verbs concrete with 3 mini demonstrations. Demo 1 is the household decision. You have an electricity bill that seems unusually high. Remove your name, account number, address, and payment details. Give the assistant the usage table and ask it to compare this month with the previous 6. Calculate the percentage change list possible explanations and separate what the data proves from what would require inspection. The useful output is not your air conditioner is broken. The useful output is a chart, a list of hypotheses, and questions for the utility or a technician. Verify the arithmetic. Do not let the model invent a cause. Demo 2 is learning. You want to understand compound interest. Ask for an explanation using $100, then a table for 5 years. Then 5 questions that increase in difficulty. Answer before seeing the solutions. When you miss one, ask the assistant to diagnose the misconception without simply giving the answer. Finally, calculate the same example independently. This is tutoring as a loop. Explain, attempt, feedback, retry, verify. Demo 3 is personal administration. You have a long warranty document. Ask the assistant to identify the coverage period, exclusions, claim steps, required evidence, and deadlines with a page reference for every item. Then compare the summary with the original. The assistant can reduce reading friction, but the warranty itself remains the authority. If the claim matters, confirm the interpretation with the company or a qualified advisor. These examples share an important pattern. The assistant does not need control of your bank account, your utility account, or your email. It can create value from a bounded copy of the information. More permissions would not improve the reasoning enough to justify the risk. Another pattern is the shape of the output. A good result is inspectable. A table can be checked. A page reference can be opened. A formula can be repeated. A checklist can reveal a missing step. Ask for an inspectable format. Make the reasoning visible instead of burying it in polished prose. Chapter 4. Real people, measurable help. Positive stories matter most when the evidence is specific. So let us look at several kinds of help and keep the limits visible. In a large workplace study, summarized by the National Bureau of Economic Research, roughly 5,000 customer support agents were observed as an AI assistant was introduced. The number of customer issues resolved per hour increased by nearly 14% on average. The largest gains, about 35%, went to less experienced and lower-skilled workers. Veteran workers saw little improvement. Some results declined slightly. The lesson is not that AI makes everyone 14% better. It is that the tool appeared to spread some patterns used by stronger workers, helping newer people move down the learning curve faster. A separate experiment published in Science assigned professional writing tasks to 453 college-educated participants. People given access to ChatGPT finished the tasks 40% faster on average, while independent quality ratings rose 18%. Again, the result belongs to those tasks, that experiment, and that generation of technology. But it shows why drafting and rewriting became early practical uses. The assistant can reduce the blank page cost. Now consider one coding benchmark. In a GitHub run-controlled experiment, 95 professional developers were recruited, and 35 completed one defined JavaScript server task. Developers using Copilot finished the task about 55% faster on average. They took about 1 hour and 11 minutes, compared with 2 hours and 41 minutes for the group without it. This is vendor-affiliated research on one narrow task with a small completed sample. Not a guarantee that every developer or every codebase gets faster. More recent research has also shown that experienced developers can slow down when tools are poorly matched to a complex, familiar repository. The right conclusion is not AI always speeds up coding. It is that task fit and review discipline determine whether acceleration is real. Education offers another human-in-the-loop example. In a randomized trial involving more than 700 tutors and 1,000 students from underserved communities, students whose tutors used Tutor Copilot were 4 percentage points more likely to master math. Topics: lower-rated tutors saw a larger effect. Their students improved by 9 points. The system gave suggestions to human tutors. It did not replace them. The study also reported suggestions that were not always appropriate for the grade level. The positive result is narrower and more useful than an autonomous teacher slogan. Timely AI guidance may help a human tutor bring more expert teaching patterns into a live session. Now move from productivity to accessibility. Be My Eyes connects blind and low vision users with visual assistants. Its Be My AI feature can describe images and answer questions about them, with the option to reach a human volunteer when needed. The organization reported 1 million sessions within weeks of its open beta and more than 30,000 questions a day at that time. Users described tasks such as reading labels, translating text, checking clothing or makeup, and understanding visual information on their own schedule. The important design choice is the fallback. AI expands access, and humans remain available when the model cannot help. In medicine, language must be careful. A United Kingdom government report described early-stage analysis of an AI-supported stroke workflow called Brain Omics eStroke. The system helped clinicians interpret brain scans and coordinate treatment decisions. The report associated the workflow with a treatment time reduction of more than 60 minutes. It also reported that the share of patients recovering with little or no disability rose from 16% to 48%. One patient story described Carol Wilson returning to work after clinicians used the tool to help diagnose a clot and recommend a thrombectomy. Clinicians, not the software, performed the procedure. Doctors made the clinical decisions. The positive story is faster information reaching trained people during a time-critical emergency. In science, AlphaFold changed access to protein structure predictions. Google DeepMind and the European Bioinformatics Institute made more than 200 million predicted structures available. DeepMind reports that more than 3 million researchers working in 190 countries have used AlphaFold resources for work connected to antimicrobial resistance, crop resilience, heart disease, and other questions. Predictions do not replace laboratory evidence. They help researchers focus scarce lab time on better candidates. AI can also support preparation before disasters. Google described a pilot with Give Directly in Mozambique during Cyclone Freddy. River flood forecasts were combined with digital cache infrastructure, so support could reach communities around the time of a warning. More than 4,100 households received transfers in the pilot. This is not a story about a chatbot predicting the future perfectly. It is a story about forecasts, local organizations, payment systems, and operational planning working together. Finally, consider a family farm. OpenAI profiled Rachel Sharp, who was preparing to take over a South Carolina seed business with handwritten crop ledgers dating to 1971. The family digitized the records and made them searchable. The useful result was continuity. Past planting dates, yields, and practices became easier to reference while working in the field. The story is reported by the product vendor, so we should treat it as a customer account rather than independent research. But it illustrates a humble use of AI, making a lifetime of human experience easier to find. Across these stories, the pattern is consistent. AI creates the most value when it is embedded in a larger human system, an experienced agent, an independent reviewer, a volunteer network, a clinical team, a laboratory, a humanitarian organization, or a family business. The tool is not the whole story. The surrounding people, data, process, and responsibility are what turn capability into outcomes. Chapter 5, Get Unstuck AT Work. Let us build a complete everyday workflow. Imagine you have notes from a meeting and need a decision brief by the end of the day. The notes are messy, people disagree, 3 numbers may be outdated. One action has no owner, A weak prompt says, summarize this meeting. A useful prompt says, turn these notes into a one-page decision brief. Separate confirmed facts, proposals, open questions, and decisions. Do not invent owners or deadlines. Flag any number that needs a current source. End with the 3 decisions the team must make next. Before you upload anything, remove secrets, customer data, private employee information, and details the chosen service should not receive. If your workplace has an approved AI policy, follow it. Without a policy, keep private documents out of the tool. Wait until a responsible person defines the boundary. Treat the first output as a draft. Ask which sentence relies on the weakest evidence. What did the summary omit because it appeared only once? Did any proposal get rewritten as if it were already approved? Where did you infer an owner or deadline? Then ask for a counterargument. If the brief recommends option A, ask for the strongest case for option B. Ask what evidence would change the recommendation. This turns the assistant from a confident summarizer into a structured debate partner. Next, verify. Open the original notes beside the draft. Check names, numbers, dates, commitments, and quotations. If the assistant used web research, open the primary sources. If it performed calculations, reproduce the important ones in a spreadsheet or calculator. If the decision affects money, people, contracts, safety, or reputation, a responsible human owns the final call. Ask for a version for executives, a checklist for the project owner, and a short message that links to the full brief. Do not let the system send anything yet. Read the message in your own voice. Remove inflated language. Confirm that the requested action is clear. This workflow can save time because one set of notes becomes several useful forms. More importantly, it can improve thinking when the challenge pass catches an assumption. Here is the attractive wrong answer. An assistant sees a number repeated in 2 meeting comments and writes, customer churn increased 12% last quarter. It sounds convincing, but perhaps one speaker meant 12% of accounts. Another meant a 12-point change, and neither had the final report. The correction is not better wording. The correction is to label the claim unverified and retrieve the source. That is why productive AI is not measured by how much text it produces. It is measured by how much reliable work reaches the next decision. A beginner can reuse this pattern for email, proposals, performance reviews, customer research, policies and planning, input, structure, challenge, verify, package, approve. When those stages are visible, speed becomes safer. And when the system says it is 90% sure, remember that confidence language is not a calibrated guarantee unless the product and task have been tested that way. Ask for evidence, ask for uncertainty, keep the original material close. The best work use is often not replacing a task. It is shrinking the low-value friction around the part only you can own. Chapter 6. Start a small project. Now imagine a different goal. You want to build a simple website for a neighborhood service, a budget tracker, a study quiz, or a tool that renames files. You are not a professional developer. AI can lower the barrier to entry, while people remain responsible for a safe and maintainable result. Start with a brief, not the code. Describe the user, the problem, the smallest useful version, the information it stores, what it must never do, and how you will know it works. For a local service website, the first version might need a home page, services, pricing guidance, frequently asked questions, and a contact form. It must work on mobile, use accessible contrast, avoid fake reviews. Collect only necessary information, and never expose private keys. The definition of done might be, every link works, the form validates input, the page loads locally. The copy is reviewed, and no external service is activated without approval. Ask the coding assistant to propose a plan before changing files. Then ask it to create one small slice. Run the result locally, test it, look at the mobile layout. Use the keyboard instead of the mouse. Enter bad data. Check whether errors are understandable. After the first version works, create a test checklist. Then request a security review. What inputs are trusted? Where is data stored? What could an attacker control? Are secrets committed to the project? Does the form actually send information? And if so, where? A coding agent may be able to read files, edit code, run commands, and inspect tests. That is more powerful than a chat window. Keep the project in version control, but do not let an agent commit, push, deploy, buy a domain, or create cloud resources without explicit approval. Make backups. Review diffs, prefer a local preview. The beginner artifact at the end of this chapter is not a startup. It is a tested local prototype with a short README, a list of known limitations, and a decision about whether it deserves another hour. That standard protects you from a common trap. The demo that looks complete but has no durable foundation. A beautiful screen can hide broken forms, insecure data handling, inaccessible navigation, invented claims, and maintenance nobody owns. AI can still create remarkable leverage here. It can explain unfamiliar files, generate repetitive scaffolding, write tests, suggest alternatives, and help you debug. It can turn an idea into something concrete enough to evaluate. For many people, that is abundance in a practical form. The cost of asking, could this work, falls dramatically. But the completed prototype is also the beginning of human questions. A responsible owner must support users and define what data is collected. What happens when the model or dependency changes? What does success cost at 10 users, 1,000 users, or 1 million? The honest claim is not that AI built the business. It is, AI helped me create and test a first version, and I now understand the next decisions better. That is a productive win. A small, reversible experiment replaced an abstract dream with evidence. Chapter 7. Operator TonkaToyXL workflow. Operator Tonka has a 6-step loop for almost any beginner task. Step 1, define the outcome. Do not begin with the product name, begin with the result. I need to understand this lease before speaking with a professional. I need a weekly meal plan under $100. I need 3 options for a customer response. I need a local prototype that proves one feature. Step 2, provide context and constraints. Who is this for? What material should the assistant use? What budget, deadline, tone, format, privacy boundary, or non-negotiable applies? A constraint is not an obstacle. It is information that makes the answer more useful. Step 3, request the first draft. Ask for assumptions to be labeled. Ask the system to distinguish source-backed facts from suggestions. For current research, require links and dates. For files, require quotes or page references. For code, require a plan and tests. Step 4, run the challenge pass. Where could this fail? What is missing? What would an expert question? Which part is most likely to be outdated? What alternative approach deserves consideration? Step 5, verify the load-bearing pieces. You do not have to recheck every adjective. Check the facts that support the decision. Totals, deadlines, eligibility, prices, plan features. Citations, file paths, permissions, and safety assumptions. Step 6, apply the human edit and stop rule. Make the result sound like you. Remove content you do not understand. Decide whether the artifact is good enough, needs another pass, or should be abandoned. A stop rule prevents endless polishing and unsafe escalation. Here is the loop in one compact prompt. Help me produce this outcome. Use only the context below. Respect these constraints. Give me a first draft and label assumptions. Then challenge the draft, list what needs verification, and stop before any external action. The phrase "stop before any external action" matters. It separates preparation from execution. A message can be drafted without being sent. A purchase can be compared without being made. A post can be packaged without being published. Code can be tested without being deployed. This distinction creates a clean trust ladder. Prepared means the artifact exists. Approved means a responsible person authorized the next step. Executed means the action happened. Persisted means the result was saved in the right place. Verified means evidence shows it worked. Finished means the original goal is satisfied, not merely that a command returned 0. The model could invent a source. The source could be real but outdated. The file could contain private data. The calculation could use the wrong unit. The generated code could work on the happy path and fail everywhere else. The automation could send a draft before review. The recommendation could reflect bias in the data. The output could be legal to generate, but irresponsible to publish. Do not respond by abandoning the tool. Respond by designing the workflow. Use primary sources. Date the evidence. Keep permissions narrow, add tests, require approval. Preserve a rollback, put uncertain cases in an exception queue. That is what mature productivity looks like, not maximum autonomy, appropriate autonomy. Chapter 8, What It Really Costs. The cheapest, responsible way to start with AI is usually not a giant bundle. It is one task on a free tier, followed by a decision based on actual value. As of August 2026, major consumer assistants continue to offer free entry points. Although availability, models, limits, and features differ by country and can change, a free tier is enough to learn the briefing loop, test writing and explanation. Compare the interface and discover whether the tool fits your life. Paid individual plans have often clustered around roughly $20 per month in the United States. The exact price shown at checkout may vary with taxes, region, App Store billing, promotions, and product changes. A subscription may add stronger models, higher limits, file tools, web research, image generation, voice features, projects, memory, or coding access. It does not automatically include unlimited use, every model, API credits, or enterprise privacy terms. Higher tiers can cost much more. They are designed for people who hit limits, need advanced workflows, use expensive models frequently, or require business controls. Teams and enterprises may pay per user and may have minimum seats or annual billing. APIs are usually usage-based and separate from consumer subscriptions. A $20 chat plan does not mean you can run an unlimited automated service. Think in budgets rather than brands. Budget zero, choose one reputable free assistant. Use non-sensitive material, complete 3 low-risk tasks. Keep a simple score, minutes saved, revisions required, factual errors found, and whether you reuse the result. Budget 20. Pay for 1 month only after the free trial exposes a specific limit that blocks a valuable workflow. Before subscribing, write the reason. I need larger files, more research, better coding access, or more daily use. At the end of the month, compare the value with the cost. Budget 50 to 100. This may cover one general assistant plus a specialist tool for design, coding, research, transcription, or media. If 2 tools overlap, keep the one that produces the most reliable finished work, not the most exciting demo. Usage-based budget. If you build an automation with an API, set a hard spending cap, log requests. Estimate the cost per completed task, and test with small data. Include retries, long outputs, images, audio, and background agents in the estimate. A workflow that costs pennies in a demo can become expensive when it loops or processes thousands of items. Hidden costs matter. Review time is a cost. Correcting hallucinations is a cost. Rebuilding a fragile automation is a cost. Training employees, protecting data, managing accounts, and documenting workflows are costs. This accounting still supports AI when it removes more friction than it adds. Here is a simple return on investment test. Pick one repeated task. Record how long it takes without AI. Use the assistant for 4 weeks. Count setup time, verification time, subscription cost, and any rework. Measure the final outcome, not the amount of generated text. If you save 2 hours a month on a $20 plan, ask whether those hours are worth more than $20 to you. If the tool also improves quality or reduces stress, note that separately. If it creates extra checking and no reusable result, cancel it. The goal is not to spend nothing. The goal is to buy leverage deliberately. Try 4 tasks for free and save the results before paying. In week 2, you identify the limit that actually mattered. Perhaps the free plan would not accept the document size. The research limit interrupted the workflow. Or the stronger coding model produced a more testable result. During weeks 2 and 3, track completed outcomes. A completed outcome might be a verified comparison you used, a report that reached a decision, a reusable spreadsheet, a tested prototype, or 3 hours of administrative work avoided. Do not count drafts that were abandoned. Do not count generated images you never published. Do not count code that did not pass its tests. In week 4, repeat the task without the paid feature. Compare the result with the free alternative. If the paid tool saved meaningful time, raised quality, or made a valuable task possible, renew. If the improvement was mostly novelty, cancel. Subscriptions are easy to accumulate because each one feels small. Review them as a portfolio. For a small business, include labor and risk. If an employee earning $30 an hour saves 2 verified hours a week, the gross time value may exceed a $20 plan. But if another employee spends 3 hours correcting errors, the workflow is negative. If a customer-facing mistake creates a refund or damages trust, the cost can overwhelm months of savings. Measure the system, not the fastest user. For creators, include rights and distribution. Generating music, images, and video may reduce production cost, but platform rules, licensing terms, likeness consent, and audience trust still matter. Track which assets are owned, licensed, captured for editorial evidence, or generated. Rights uncertainty can create an expensive problem. For agents, include authority. A read-only research agent is cheaper to supervise than one allowed to purchase, publish, delete, or message people. The more consequential the action, the more value you should place on approval gates, logs, and rollback, not merely the model price. Before paying, verify the live pricing page. Plans change. Features move, limits tighten or expand, regional availability differs. This documentary is a dated guide, not a permanent checkout screen. Chapter 9. The abundance question and where AI breaks. Abundance is a big word. In this film, it does not mean infinite wealth or a guaranteed future. It means the cost of producing a first useful attempt can fall. A student can ask for another explanation without feeling embarrassed. A small business can draft a policy before paying for expert review. Scientists can narrow a search space, while creators can storyboard 10 directions before choosing one. A programmer can test an idea over a weekend. A person with low vision can ask a visual question at the moment it matters. A community can combine forecasts with logistics before a flood arrives. When the cost of trying falls, more people can participate. More experiments become possible. Some ideas that would have died in the blank page stage can reach the point where reality judges them, but abundance of output creates new scarcity. Attention becomes scarce because everyone can produce more. Trust becomes scarce because polished content is cheap. Quality becomes scarce because first drafts can masquerade as finished work. Distribution, energy, rights, training data, secure infrastructure, and human review remain limited. Research shows this jagged edge. A study followed hundreds of consultants using GPT-4 on a creative product innovation task. Their work received ratings about 40% higher than the group without AI. On a business problem-solving task deliberately placed outside the model's competence, the AI-assisted participants performed 23% worse. Many accepted persuasive but misleading output. That is the abundance paradox. The same system can expand capability on one task and quietly damage performance on the next. Expertise changes from knowing every answer to knowing how to frame, test, and reject answers, but domain knowledge still matters because it helps you detect when the tool has crossed its frontier. AI breaks when we confuse confidence with correctness. It breaks when a system invents a citation, compresses uncertainty, or chooses a plausible number. It breaks when private data enters a tool without informed permission. It breaks when an automation acts faster than a human can notice. It breaks when generated code is deployed without tests, security review, or an owner. It breaks when a creative system copies style or material in ways that ignore rights and consent. It breaks when the people most affected by a decision cannot appeal it. It also breaks socially. Productivity gains can be shared, or they can be used only to increase pace and surveillance. New access can reduce inequality, or expensive tools can widen it. Workers can receive better tools and training, or they can be judged against output targets created without understanding the work. Abundance is not distributed automatically. Institutions and choices determine who benefits. A positive documentary should not hide these facts. The responsible optimistic position is that AI can be genuinely useful, and that usefulness is shaped by design. Use a keep, verify, stop rule. Keep the parts that are low risk, understandable, and helpful. Verify the facts, calculations, permissions, and decisions that carry consequences. Stop when the system asks for authority it does not need. when you cannot inspect the result, when the evidence is weak, or when a qualified human is required. A worthwhile future keeps people in the loop. It is one where more people gain the ability to learn, make, solve, and participate while responsibility remains human and visible. Chapter 10. Your 7-day starter plan. You do not need to remember every benchmark in this film. You need a first week that turns curiosity into evidence. Day 1, choose the tool and the boundary. Pick one established assistant with a free tier. Read its privacy controls. Do not upload secrets. Choose a green task. Explain a concept, rewrite your own notes, or make a checklist. Write down what success means before you begin. Day 2, practice context. Give the same task twice. First, use a vague prompt. Then include the goal, audience, constraints, evidence, and definition of done. Compare the outputs. Notice how much quality comes from the brief rather than the brand. Day 3, challenge the answer. Ask for assumptions, missing information, counterarguments, and possible failure modes. Find one attractive sentence that sounds stronger than the evidence. Rewrite it honestly. Day 4, verify. Choose a research question with a checkable answer. Require primary sources and dates. Open each link and confirm that the source says what the assistant claims. If it cannot verify something, label the gap instead of smoothing it over. Day 5, make an artifact. Turn your work into something usable. A one-page guide, a study quiz, a meal plan with a shopping list, a spreadsheet template, a local web page, or a decision brief. Test the artifact with the person or situation it is meant to serve. Day 6, repeat the workflow. Use the same input, structure, challenge, verify, package, approve loop on a second example. Record how long it took and what failed. A repeatable process is more valuable than one spectacular answer. Day 7, decide whether to keep the tool, change the workflow, try another product, or stop. If a paid feature would remove a real limit, consider 1 month and measure it. If the free tier already solves the problem, keep your money. If the tool creates more work than it removes, that is useful evidence too. At the end of the week, make a one-page AI operating note for yourself. List the tool you used, the kind of data you are willing to provide, the tasks it handled well, the tasks that required heavy correction, the sources you trust, and the actions that always require your approval. This note becomes more valuable than a folder of random prompts because it records your boundary. And your evidence. Choose one workflow to keep, give it a name. Maybe it is Monday planning, document questions, customer response draft, study coach, or local prototype review. Write the input, the expected output, the verification step, and the stop rule. The next time you use it, improve the workflow rather than starting from zero. Share the lesson, not private data. Use a harmless example when showing AI to family member or coworker. Show the flawed first draft and the correction, not only the impressive ending. Responsible adoption grows when people can see both the leverage and the inspection process. And keep one human-only space. Not every journal entry, conversation, sketch, or decision needs a model. Productivity is not measured by how completely technology occupies your life. The point is to recover time and possibility for the parts you value. Here is your first prompt. I am new to AI. Help me complete one low-risk task today. My goal is this. The context is this. These are my constraints. This is what a useful result looks like. Give me a first draft, label your assumptions, tell me what I should verify. And stop before any external action. Then keep the conversation going. Ask for a simpler explanation. Ask for 3 options. Ask what could go wrong. Ask for the source. Ask for a checklist. Keep editing until the result feels like your own. AI is not just a place to ask trivia questions. It can be a practical layer between a goal and a first draft, between confusion and a learning plan, between scattered notes and a decision, between an idea and a prototype. You do not have to believe every promise. You do not have to ignore every risk. You can start smaller than the hype, one real problem, one clear boundary, one useful result, one human responsible for the final decision. That is how productive AI earns trust. And if enough people gain that kind of leverage, carefully, affordably, and with the ability to say no, the road toward abundance begins not with a machine replacing us, but with more people able to participate in making what comes next. Operator Tonka's final rule: prepare freely, verify carefully, approve consciously. And never confuse a polished output with a finished outcome. AI stories that actually matter.